looking at Kirchhoff's current law and Kirchhoff's voltage law. So what's Kirchhoff's current law? Kirchhoff's current law states that at any junction in an electric circuit, the total sum of currents entering a junction is equal to the total sum of currents leaving that junction. That is, look at this diagram. We assume that this is an electric circuit. This is a junction. So the total sum of currents entering this junction, like now, I1 is entering this junction, I2 is entering this junction, but I3 is leaving, I4 is also leaving, while I5 is also leaving. So the total sum of currents entering this junction is equal to the total sum of currents leaving this junction. Now let me apply it for now. The total sum of currents entering the junction, I1 is entering, right? Plus I2 is equal to I3, which is leaving, plus I4 plus I5. Simply, this is the simple application of Kirchhoff's current law. The total sum of currents entering the junction is equal to the total sum of currents leaving this junction. This is a simple application of Kirchhoff's current law. So, what you don't need to do is know the law, then you'll be able to apply it. That's simple. Don't need to plan. Just understand the law. Total sum of currents entering the junction is equal to the total sum of currents leaving the junction. So now, we have a question here that says, find the unknown currents marked in the diagram below. This is a diagram. It says, we are looking for I2, I1, I3, I5, and I4. Now, let's define a junction. A junction is a point where two or more currents meet. Now, starting from junction A, this is not a junction because we don't have two or more currents meeting here. It's only 50 ampere that is meeting here. So we started from junction B. For junction B, you will notice 20 amperes is leaving this junction. I1 is leaving this junction. While 50 amperes is entering the junction. See the direction. It's entering the junction. 20 amperes is leaving, while I1 is also leaving. So, from the current for the Kirchhoff's current that states, the total sum of currents entering the junction is equal to the total sum of currents leaving the junction. Now, for my junction B, the total sum of currents entering the junction. So I'll have to look for the current that is entering the junction. Now, 50 is entering the junction. I'll say 50. If that point, nothing is entering. The only 15 ampere that is entering is equal to 20 plus I1, because 20 amperes is leaving, while I1 is also leaving. So, our normal mathematics, making I1 the subject of the formula, we will say I1 is equal to 50, while 20 comes to the other side will become minus 20. Now I1 is equal to 30 amperes. Now move on to junction B. So this is what we have for junction B. So move on to junction C. For junction C, we have 20 amperes entering the junction, 15 amperes entering the junction, while I2 is leaving the junction. So we say junction C, 20 amperes entering the junction, 20 plus 15 entering is equal to I2, which is leaving. So 20 plus 15, we have what? 35 amperes. I2 is equal to 35 amperes. So move on to junction D. For junction D, 120 amperes is leaving the junction. I3 is also leaving the junction, while I1 is entering the junction. So inputting using my Kirchhoff's current law that states the total sum of current entering the junction is equal to the total sum of current leaving the junction. Now, I have my I1 entering the junction. I1 plus, okay, you don't have any other current entering the junction, equals to I3, which is leaving, plus 120, which is also leaving the junction. Right? So, yeah, you can see we have two unknown. But if you can recall, in junction B, we have gotten I1, which is equal to 30 amperes. All we just need to do what is to do our normal mathematics. Inputting 30 amperes, replace it with I1. So, which we have gotten in junction B. 30 is equal to IP plus 120. Now, you make your IP the result of the formula. So, IP is equal to 30 minus 120. So, our IP is equal to what? 20 minus 120 becomes minus 90 amperes. So, move on to junction E. So, let's put it over the board. Move on to junction E. For junction E, we have I3 entering the junction. I3, let me write it out for you. Junction E. Junction E. I3 is entering the junction. I3 plus I4 entering the junction is equal to I5, 15 amperes leaving the junction. I have gotten our value for I3. So our value for I3 before I wrote up the board was what? Minus 90 amperes. If you recall, if you check before I wrote up the board, we have minus 90 amperes as I3. Because our I4 is unknown, equals to 15. Now, to get our I4, we make I4 the center of the formula. So our I4 is equal to 15 plus 90. Then our I4 is equal to 105. Is equal to 105 amperes. Now, move on to junction F. The junction F. For junction F, 120 amperes is entering the junction. 120. No other current is entering the junction. Others are leaving. We have I4, I5 is leaving the junction. I5. I5 is leaving the junction. I5 is leaving the junction. While 40 amperes is leaving the junction. So you are still applying our Kirchhoff's current law that states the total sum of current entering the junction is equal to total sum of current leaving that same junction. So we have 120. So all you need to do here is what? To make our I5 equal to the formula, I5 is equal to 120 minus 40. So we have I5 is equal to what? 80 amperes. You can see. All you don't need to do is to know your law, Kirchhoff's current law that states the total sum of current entering the junction is equal to the total sum of current leaving the junction.